All right, so there's a few things to remember when we're doing area of quadrilaterals with perpendicular diagonals. First of all, perpendicular means, oops, there we go. Perpendicular means cross with right angles. So when we're talking about two lines that are perpendicular, there's a right angle. When we talk about squares, the sides are perpendicular because they all meet at right angles. So, and you might have noticed when we were doing the area of triangles, you always had to have the two sides that met at a right angle. That was your base and your height. So it's important a lot of times that there's perpendiculars because that's where you're going to find your base and your height. Okay, then the diagonals are the lines that connect opposite corners. And if your paper doesn't have room to write these definitions, you can add them to the top or wait till I finish. Okay, so we had three quadrilaterals that have perpendicular diagonals. Square was one. Rhombus was one. And I don't remember the other one. I'll have to come back to that. Rhombus, square, and kite. That was the other one. The kite. Okay, so we are looking at quadrilaterals with perpendicular diagonals. So we're either going to be looking at squares, rhombuses, or kites. So these two examples right here, or these two discoveries, are both kites. So you can see, here's our right angles. And if you think about the kite as two triangles, and we're looking for the area of the two triangles, then diagonal 1 and diagonal 2, one ends up being the base of the triangle, you can see that's shaded, and the other one ends up being the height of the triangle, but it's really 1/2 of that because we're only looking at half of the quadrilateral. So if you look at this top half right here, the base is diagonal 1 and the height is half of diagonal 2. So if I have two triangles, that means I'm going to have the area is going to be 1/2 base times height. But remember, our height is base is diagonal 1, and the height is 1/2 of diagonal 2. But remember, there's two of them, so I can cross this half out, but I'm still left with a half. So when you're finding the area of kites, you're going to use the formula the two diagonals times 1/2 times each other times 1/2. Because we have two triangles and the triangles end up meeting in the half of the diagonals. All right, so same thing for this one. Here's diagonal 1, which is going to be diagonal 1, which is going to be my base. Diagonal 2, which is going to be half the height, right? So that when I multiply base times height, I'm going to end up dividing it by 2 because I have two triangles, but I'm only using half of the diagonal for the height. Okay, so if I'm looking for the area of a quadrilateral, with perpendicular diagonals. So here's D1 and here's D2. So I'm going to do the area 1/2 15.4 times 9.7, or you can think of it as 15.4 times 9.7 divided by 2. And my units are meters, so I'm going to end up with 74.69 square meters. Okay, and then since we're working backwards with example number 2, I'm given the area and I need to find D2. So I'm going to use my same formula, except I know the area. D1 is 14, and D2 we don't know. So I'm going to multiply 14 times 1/2 or divide 14 by 2. And I end up with 7 times D2. I divide both sides by 7. And I end up with D2 equal to 34. And my units are inches. Your paper may not have a space to write how you find the area of quadrilaterals with perpendicular diagonals, but it might be good for you to think about how you would write it in your own words, how to find the diagonal, and a way maybe to remind yourself that there's a half in there. Okay, so now I have a square. This one still has perpendicular bisectors, and I'm still going to use the same formula. I'm still going to use area equals 1/2 D1 times D2. So for this one, BE equals 5, EC equals 8. The sides are all the same. Perpendicular bisectors mean they bisect, which means I know all 4 of those. So diagonal 1 is 10, and diagonal 2 is 16. So my area is going to be going to be 1/2 10 times 16, and that is equal to 80 meters squared. Okay, so if I need to find the perimeter also, I found the area, but I also need to find the perimeter. So if I'm going to find the perimeter, I need the length of one of the sides. So I'm going to use my Pythagorean theorem. And I'm going to do 8 squared plus 5 squared equals c squared. So I have 64 plus 25 equals c squared. 89 equals c squared. So c is equal to the square root of 89. So if I'm going to do perimeter, I can just do 4 times the square root of 89 and leave it just like that, because I know there's 4 sides that are the square root of 89, and if I multiply them times 4 or add them all together, I have 4 sides times the square root of 89, and that also has the units of meters. Okay, so here's another square. Since I have an X, I'm going to leave my answer is going to have an X in it. I'm looking for the area, using the same formula. So my D1 is X plus 2. My D2 is 6. I'm going to assume that's the whole diagonal. So my area is going to be 1/2 x plus 2 times 6. So remember, when you're doing multiplication, you can do whichever ones you want to in any order. So I'm going to multiply my 1/2 times my 6. And I'm going to end up with a equals 3 times x plus 2. Or a equals 3x plus 6. Either one of those would be a correct answer. Okay, example 5, we have a kite again. Still doing the same thing. So we need to find x and y and the area of the kite. Alrighty, so the y is bisected, so these two guys are the same, but x is not bisected. So let's take this triangle right here, and let's use Pythagorean theorem. We're going to have y squared plus 28 squared equals 35 squared. So y squared equals 35 squared minus 28 squared. So remember to square those before you subtract. And I end up with y equals 21 when I find the square root. So this one's 21, this one's also 21. And if I know that, then I can find x by using this triangle. And now I know that x squared plus 21 squared equals 29 squared. So x squared equals 29 squared minus 21 squared. And when I finish that one, I'm going to get x equals 20. So I have my x and my y. Okay, so my D1, we'll say, is 28 plus 20. So that's going to be 48. My D2 is going to be 21 plus 21, which makes 42. And so my area is 1/2 42 times 48. So I'm going to do 1/2 times 42. I'm going to do this part first. And I'm still going to need a calculator over here. So it's going to be 21 times 48. So the area is going to be 21 times 48. I'll race you to see if you can figure it out before I do. 21 times 48 equals 1008. And the units would be square inches. Okay, and then last one. Again, we have the area, and we're trying to find one of the diagonals. So my formula, I'm going to have area equals 1/2 D1 times 4y. So, and my area is 28xy equals 1/2 diagonal 1 times 4y. So I can multiply my 1/2 and my 4y together, which means I have 28xy equals D1 times 2y. I'm going to divide both sides by 2y. So my y's cancel out. And I end up with D1 over here. And I end up with 28 divided by 2, which is 14x for my D1. So D1 is 14x. If I multiplied that times 4y, and divided by 2, I would get 28 xy. Centimeters squared, so that means this is centimeters, which I can't write right there. So it's really D1 equals 14x x centimeters. All right, so one formula for all the different shapes, all three different shapes we had that had perpendicular bisectors.